Hello friends, welcome back to the tetrahedron chemistry classes. So guys, in today's lecture I am going to explain a problem which has been asked in the CSIR NET examination, and I didn't solve this problem in my memory based question because honestly speaking this problem was not in my memory actually, and one of my subscriber has sent this problem and he wants the proper explanation how we can decide the topicity of the hydrogens attached to the system. So if you focus here, right, at the bottom of the picture you can see on the left top of your screen, these are this is the biphenyl system. So what is the meaning of the biphenyl system? In the biphenyl system, two phenyl rings would be attached by a single bond, right? Say if you consider this ring as ring 1 and this ring as ring 2, so these two ring in the biphenyl system, generally they shares the same plane, right? If I actually put the plane, then both these rings will actually have which will share the same plane, right? And this will happens to continue as long as the ortho positions of the two phenyl rings are not properly substituted. You can see this is the ortho position. I am writing with the O these ortho positions. So there are four ortho positions, right? And these ortho positions are vacant, and due to the vacant four ortho positions, these two phenyl rings are in the same plane, right? And now coming back to the problem which has been asked in the CSIR NET examination, right? And the problem is just I have shown over there, right? Okay, so this was the problem. You can see the two rings are there, and see if it is the ring 1, okay, and this one is the ring 2, and you know that ortho position, this is substituted with the methoxy group, and this ortho position is substituted with the methyl group, while for this ring actually the two ortho positions are substituted with the ethyl. So this is another way of writing ethyl, in which I have shown the two methylene hydrogens, but here I haven't shown those methylene hydrogens, right? And they have asked the question, what is the relationship between HA and HB, whether they are enantiotopic, homotopic, or di-stereotopic. So today we will solve this particular problem, okay? So first of all you have to understand this point, right? See, all four ortho positions are properly substituted. That means these two rings will not share actually the same plane, and they will actually have the relationship just like that. That means these two actually rings are orthogonal to each other. You know, this plane and this plane, they are forming the 90-degree angle. The meaning is that these two rings are orthogonal to each other, right? And these are the basic things in the stereochemistry. I have explained in the axial chirality these things. You can go through, see, I will give you the link in the description box, right? And you can go through the lecture and understand how we can draw these things, okay? So now you can see uh, the proper relationship, how we can decide. So whenever you are deciding for the groups or the hydrogens, say for example, if you have given two hydrogens like HA and HB, and if you can relate these two hydrogens by sigma plane, that means you can you if you are able to put a plane between the two hydrogens and then they are indistinguishable to each other, this is the simplest way of doing. That means in that case your hydrogen would have the enantiotopic relationship, so they would be enantiotopic, right? So I can write, okay, enantiotopic, okay. And if your two given hydrogens like HA and HB, if they are related with the CN axis, you know, the proper axis of rotation, and these things I have explained in my group theory lecture, elementary group theory lecture. I haven't completed that lecture series. So it may have the C2 axis, it may have the C3 axis, or any other axis, right? If the groups are related by CN axis, then definitely they are homotopic. Homotopic. If your hydrogens actually are not having sigma plane and not having any CN axis of CN axis, say both are absent, then definitely the relationship between the two hydrogens like HA and HB, the relationship would be distereotopic. Distereotopic, right? Now coming back to the problem, if you see here, If you want to, if you put the imaginary plane, right, if you put the sigma plane over there, just like that. So by putting this plane, you can see here, this is the methoxy part and this is the methyl part. So they are not actually the identical one. That means the molecule is not having any sigma plane. When it is not having the sigma plane, then there is no question of enantiotropic nature. So these two hydrogens cannot be enantiotropic, which are attached to this ethyl group, right? And then you can check the homotopic relationship. And to check the homotopic relationship, what you can do, you can say, you can put an axis, right? This is proper axis, and you can rotate this by 180 degree, right? 180 degree rotation means C2 axis, right? C2 axis. So if you rotate, right, if you rotate this structure, then what it will result actually, it will give you this structure. This is the benzene ring, okay? And after 180 degree rotation, this methyl will go over there, so you can write methyl here, and this methoxy will take the position of this, just like that, and these two will remain same. So this is your part which is coming towards you, okay? So this is ethyl, this is also ethyl. So again you can see this picture as well as this picture, they are not actually the identical one. That means it is not having the C2 axis, okay? When it is not having the C2 axis, it cannot be homotopic. So there is no option of homotopic, there is no option of enantiotropic, and the molecule is lacking actually sigma as well as CN axis. That means the relationship between these two hydrogens, like your HA and HB, they must be distereotopic in nature. So these two hydrogens are distereotopic in nature, and this question has been asked for the 2 marks in your CSIR net examination. It is the easy problem, but you need to know the certain symmetry elements and certain way to a certain trick to actually decide these things, right? So this is the simplest way in which I can explain the things. However, other methods are also there, and I'll discuss those methods in detail when I'll make the video on this topic. I hope you will like the lecture, like the explanation. If you really like the explanation, please share the tetrahedron chemistry classes with your friends also. Okay guys, thank you very much.